All right, everybody. Sorry about my picture there. My gray sweatshirt doesn't work very well with my green background. They're a little too close in color, so you're going to see me kind of halfway here. Anyway, quick, got the notes again. This key is scanned. If you'd rather just copy it, but if you like listen to me, I'm going to walk through them real quick. So, primary colors: red, green, and blue. My green crayon that I use is a little more yellowy, but that's what we got. Red, JW uses the other ones. Red, green, and blue. Secondary colors: red plus green is yellow. All right, so secondary color yellow. Green plus blue gives us cyan, and red plus blue gives us magenta. I messed up the two reds. That should be red and blue. All right, so that's how we get these secondary colors: yellow, cyan, and magenta. All right, went through this in the video, but I was talking through this while you were taking notes, so here they are in the notes. Pigments. Pigment is the color, so magenta pigment absorbs green, and it reflects red and blue. Yellow pigment absorbs blue, and it reflects red and green. And I'm looking at these. My blue looks like a cyan. My green looks like a yellow. It's all kinds of messed up. But sorry about that. Blue, red, green. RGB. RGB. Anyway, cyan. Cyan, that light blue color, absorbs the red and reflects off blue and green light. A red pigment absorbs both the green and the blue and reflects the red, and black absorbs all of them, absorbs everything and reflects nothing. That's why it appears black. All right, shift over to letters for these. Well, filters. So if you have a filter, it's the exact same thing as reflected, except we call it transmitted when it's a filter. So a green filter absorbs red and blue, transmits green. Cyan filter is going to absorb red, transmit blue and green. A red filter is going to absorb blue and green light and emit through red. So if the red is red, it'll go through. A yellow filter absorbs blue light and lets through red and green, making a yellow color. A blue filter absorbs red and green and lets through blue light. And finally, a magenta filter absorbs the green but lets through the red and the blue. All right, go through these next ones. I mean, the key's done, but I want to use the duck as I do each of these. So the first one: what color does a green leaf appear under a white light? So if we shift over, think about the duck. We need a green duck. So white light, we're going to have red, green, and blue light all coming off of the white light. And then that color off the duck, which of these are going to reflect off of green? Well, green absorbs red and blue and reflects green. So the next step, boom, only the green light reflects. There is no filter in our example, and so the object goes right to our eye with the green light from the object until the object appears green. Pretty straightforward, but again, thinking about each of the different steps: what color is the light given us, what color is reflected, and if there was a filter, which of those colors are getting through. All right. So I've got white, 3 colors coming off, green object, only the green reflects into the eye, so we see green. Number 2, what color does a magenta t-shirt appear under blue light? Drawing looks pretty simple, but let's take a look at it with the duck. So in this case, I've got white light, all 3 colors. I've got a magenta object. Oh, sorry, no, blue light. Blue light. Blue light, only blue, hits the magenta. So magenta, does it reflect this blue light? Absolutely. Magenta reflects red and blue, but there is only blue. So the blue hits the magenta object and reflects off into your eye, and so the duck appears blue, because magenta can reflect, or does reflect, blue light. All right, so appears blue. Number 3, what color does a cyan ball look under white light when it goes through a magenta filter? So we need a cyan duck. Let's back it up. White light, and we need a magenta filter. So 3 steps here. White light, What color light comes off the light? Well, all of them. All three. Red, green, blue. Cyan object. What colors get reflected off of cyan? Well, cyan is reflecting green and blue. It's absorbing the red. And then a magenta filter. What colors does a magenta filter allow through it? Well, it allows red and blue, but there is no red. So the only color that's available to get through that is the blue. And so what color does the duck appear? The duck appears blue. So a cyan ball under white light, looked at through a magenta filter, would appear blue. All right, and so we've got that drawn in here as well. Finally, number 4, what color does a red shirt appear under a magenta light that goes through a green filter? So, let's get our duck, back it up. I've got, oh, I forgot which ones they were. What do we got? We got red and magenta. Red, magenta, green. Okay. So we've got a red object under magenta light through a green filter. So magenta light, red object, green filter. What color does the duck look? All right, start out, magenta. What colors of light do I get from the light? Well, I get red and blue. Red and blue light from the light. Okay, those hit the duck or the object. What colors, which of these two, right, are going to be reflected off of red? Well, a red object reflects red light. Boom. So that gets to the green. So then we're at the filter, and it says, what are you think? What colors can transmit through green? Well, green only transmits green. So the red is not going to get through the filter. So no light gets through. And so the duck will appear black. The duck will appear black when looked at through a green filter under magenta light. And there is that there. Hope these are helping. And see you guys, like I said, see you guys on Monday.